Hello, everyone, and welcome to Why Users Are Choosing Inventor over Solidworks. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is Jim Dumont, our applications specialist. At today's webinar, we will go over some of the reasons why users are choosing Autodesk software over SolidWorks. Throughout the webinar, you can ask a question at any given point on the left-hand corner. You can ask Jim to revisit a step or ask any questions. This is your time, and we want you to make the most of it. And in the upper left-hand corner, you will find links to our social media and website. Also, make sure to check our YouTube channel. We post all of our webinars there at the end, so you can share with colleagues or watch it on your own time. And without further ado, we'll pass it on to Jim. Hi, Jim.
Hi, Juliana. Thank you very much. Hello, everyone. Thank you for joining us today. I'm just going to share my screen. And let's see here. I got the right one. Okay, great. Well, again, thank you. And thank you for joining us today. So in this presentation, we want to discuss some of the reasons why users choose the product design and manufacturing collection, not just the Inventor, but the actual collection over SolidWorks. This presentation by no means is meant to bash SolidWorks, but to highlight the features and benefits that draw users to Autodesk. Now, there are many differences, and within the time restraints, we don't have the luxury to demonstrate each feature that separates the programs in depth. We're going to cover basically the topics of what they are. In your question or Q&A or reaching out to Juliana, if you have any need or any desire to find out more in-depth information about any topic that might be useful to you, please reach out and we can schedule a personal demonstration for that particular feature if necessary.
Absolutely.
So what is the product design and manufacturing collection? So Autodesk came up with this idea as far as a solution. They didn't want to just create a product inventor and have all these features in it. Because so many of us have cross disciplines in which we work, they came out with a collection. It's a powerful set of applications that provide extended capabilities to Inventor and AutoCAD for engineers who design complex and custom products, equipment, and systems. So with the collection, you can extend Inventor with a lot of add-ons for tolerance analysis, simulation, and production layout. We can use connected products for 2D drafting, large-scale design review, and visualization. We can connect to Fusion 360 to access Autodesk's next-generation capabilities and their collaboration tools. Let's first discuss engineering design workflows. And the first one we want to discuss is the cloud-based 3D CAD. Cloud-based or online CAD software, it runs in a local browser or through a web or mobile app. Unlike traditional software installed on a local computer, you don't need to do any of that. You simply go online and it's there and it's always up to date and active. They offer many of the same capabilities as traditional CAD software, but are updated through a remote server and are acquired through a subscription, and it's usually monthly or annual. It allows you to work remotely and collaborate with colleagues with AutoCAD and Fusion 360 from an internet browser. So in addition, AutoCAD, LT, AutoCAD Web, and the mobile app offers connected workflows through some of the leading cloud storage providers, including Box, Google Drive, OneDrive, and Dropbox. Currently, it's in regards to SolidWorks, this workflow is only available as an add-on for the 3 levels of software. So the 3 primary levels that we're going to discuss with SolidWorks today are their standard, professional, and premium versions. So this capability is available, but strictly as an add-on. This one is very big. This is a rules-based design automation. When we hear rules-based design, we typically think and mean Inventor iLogic. So approximately 1/3 of everyone with a seat of Inventor uses iLogic regularly. It's a rules-based design engine that it's one of the most powerful and effective ways to save on time. You can define the rules to quickly reconfigure your designs. This helps to satisfy the customization demands of your customers. You can even use it to generate an instant quote. And because you can quote faster and more accurately, you'll be able to get your designs to manufacturing faster. It's also important to understand the scalability of the work you do in Inventor. So what happens when you want to make your forms available to people who don't have Inventor, outside of the engineering? Maybe it's sales. How can customers fill out forms from any location? So when you're ready to take on the next step of automation, MicroCAD will be here to help you with Autodesk Forge. It's an automation API for Inventor where you can experience the advantages of running iLogic in the cloud. Solidworks does have some of these capabilities. It's very limited in all three levels of their software. Continuing with the engineering design workflows, we look at topology optimization, and the first one is lightweighting. So what is lightweighting? It's how we can improve the strength to weight ratios by removing excess material that is not necessary for the design's performance requirements. We look at shape optimization. It's a technology that helps inform certain geometry decisions to specific conditions such as manufacturing methods. Maybe it's conventional subtractive machining, or maybe it's additive. You're doing 3D printing. Structural compliance, calculate the physical response of a given shape, depending on the forces the shape is subjected to. So this type of technology is only available as an add-on for SolidWorks in all three of its levels. So it is available, but these are all add-ons. So you're increasing the cost of the software considerably with each one of these add-ons. Generative design is something that's very unique and very new to a lot of CAD users. It's basically what it is. It's a way of design exploration. Designers or engineers can input goals into their generative design software along with parameters such as performance or spatial requirements, materials, manufacturing methods, and cost constraints. The software explores all possible permutations of a solution, quickly generating design alternatives. It tests and learns from each iteration of what works and what doesn't. So as you can see here, not only did this capability help General Motors in the top right hand of this this slide, the General Motors was able to design a seat belt bracket. It was 40% lighter, 20% stronger, but more importantly, it was also be able to consolidate an assembly from 8 parts into 1. So it made it simpler and faster to install. The second example is from a company called MJK Performance. The team was able to develop concepts faster, being able to do this and select their final design based on cost and time it would take to manufacture. Now, the General Motors, that's great. It's very organic and be able to do that with 3D printing or casting. That may not be the best method. It's also a consideration you want to take as far as you want to consider the cost of what it takes to get to that final design. So in MJK Performance, traditional 3-axis machining was appropriate for them. Then in the little image that I have in here this is a popular bicycle manufacturer called SRAM, and they're using the technology to explore more options in some of their component designs. So when it comes to electrical engineering, the collection includes AutoCAD Electrical. We're able to create, modify, and document electrical control systems with an industry-specific tool set. So out of the box, AutoCAD Electrical includes more than 65,000 schematic symbols. You have the ability of creating automation of your wires and component tags, automatic reports, support for electrical standards, NFPA, IEC, JIC, circuit design and reuse, SQL support, SQL catalog support. So if you have a large team of electrical users, that database can be driven by SQL, which handles the information and the throughput much better than Microsoft Access. Coil and contact cross-referencing, and then PLC, IO drawings from spreadsheets, and so much more. So this technology is only available as an add-on for all three levels of SolidWorks. I do want to back up a little bit. I did forget to mention, as far as the generative design, this technology is not available in SolidWorks. So within Fusion, which is also part of the collection, so there's Inventor, there's Fusion 360. So there are some technologies that are very similar between the programs, and there's some that are very different. In this particular example, PCB design is exclusive to Fusion 360. So from the initial schematic diagram to PCB layout with layer definition to create the 3D board representation, it can all be created within Fusion 360. Autodesk also just launched signal integrity for Fusion 360 electronics, which tests for electromagnetic compatibility and interference within your PCB design. So this extends what users can develop within Inventor by enabling a bi-directional flow of information. For example, a space envelope that was designed in Inventor could be pushed over to Fusion, say an enclosure. This enables the designer in Fusion to create the PCB within the context of the enclosure, and then once it's complete, that information can be pushed back to Inventor for a complete design, so we can see the PCB, the entire design, and the enclosure as one. And as far as I know, this technology is not available in SolidWorks. Continue with the AutoCAD Electrical, Fusion 360, and Inventor compatibility bi-directional. The collaboration between mechanical and electrical teams can be challenging. But what if electrical and mechanical designs could talk with each other? That's why the electromechanical workflow between AutoCAD Electrical and Inventor was developed, is basically also known as EMX, it's the electromechanical exchange. Schematic diagrams can be created within the 2D toolset, which is the AutoCAD Electrical. Inventor electromechanical ensures both parties are aware of what's happening, basically in each other's designs. So not only are you able to share up-to-date information between your electrical schematics and your Inventor 3D models, it also gives the mechanical designer the ability to generate 3D cable routes. So if space is tight, approximate clearances can be accommodated, and an accurate bill of materials can be generated. We're able to see it by in real time 3D wire routes. We're able to create nail boards for pre-manufactured assembly. We're able to get wire lengths, so for our costing and estimating for large quantities, it would be extremely much more accurate. And from my understanding in SolidWorks, this technology is only available as an add-on to their premium offer. So in addition to its specialized modeling tools, Inventor has tube and pipe, or tube and pipe runs. So Autodesk tube and pipe runs is an add-on. And the add-ons, as far as the tube and pipe, when we get into the simulation, these are all included within the product design and manufacturing collection. There's no extra software that you have to purchase. It's all completely inclusive. It adds design tools for routing rigid pipes, bent tubes, and flexible hoses to mechanical assemblies or product designs in the assembly environment. For SolidWorks, this technology is only available in their premium offering. Continue with 3D mechanical design. Autodesk and the collection has these design accelerators. The design accelerators represent an important component of functional design. Engineering calculations and decision support identify standard components or create standards-based geometry. Now, SolidWorks does have similar technology in all three of the levels, but all as an add-on. When we extend the capabilities of the engineering workflows to factory layout, it allows you to quickly validate factory floor layouts for efficient equipment placement to improve production performance. Currently, this technology is not available in SolidWorks. Now I'm going to start talking about conceptual design workflows. And in here, we're talking about T-spline technology. Some of you may not have heard of it before, but what is T-spline technology? Simply put, T-spline technology is a surfacing technology that reduces the effort to create complex shapes. If you've ever done any complex surfacing in the past, it's very difficult. They're not very much associative and parametric. With the T-spline technology, it is. And this technology also is not available in SolidWorks. Simulation workflow. So let's take a look at some of the advanced simulation workflows. Most 3D CAD software nowadays has some entry-level FEA. Many of you use it, which is great. Every license of Inventor Professional, for example, comes with stress and frequency study types. However, Nastran offers a complete set of tools for simulation workflows. For example, dynamic simulation. You can simulate and analyze the dynamic characteristics of an assembly in motion. Assembly level FEA. You can analyze stress, deflection, and frequency levels for parts and assemblies. Parametric optimization. You can optimize the weight and strength of your design by running a combination of variable dimensions. So these three technologies are available in SolidWorks, but only in its premium package. When we continue on with the simulation, we get into nonlinear, so I can gain accurate results for materials containing nonlinear stress strain curve data. Thermal, I can check temperature distribution and use results to determine the thermal expansion. Fatigue, predict fatigue life based on a number of load cycles to failure. Vibration, I can monitor the levels and patterns of vibration signals within a component, machinery, or structure to detect abnormal vibration events and to evaluate the overall condition of the test object. So for nonlinear, fatigue, and thermal, these are available in all levels of SolidWorks as an add-on. We start talking about communicating workflows. Most of us do work in multidiscipline environment. We have customers that work in both the BIM and the manufacturing space. Multi-CAD data aggregation is a big deal. So one of the challenges that you might often face is coordinating and communicating designs for review. So although many CAD systems can import information from other sources, it is often difficult to manage change. And depending on the complexity of the information, it may become challenging, especially when you have a model that contains hundreds of thousands or even million plus components. This is where Navisworks comes in. This application is not only built for design review and walkthroughs, but it can also be used for clash management of models imported from other CAD systems, in addition to non-CAD data such as point clouds. With timelining in Navisworks, equipment information can be synced to your project management software. This will help to assist the installation process of your design. Again, all of this can be accomplished while the data remains associative to the model data. So for SolidWorks, it has limited capabilities for walkthrough and fly-throughs in all three levels. However, the multi-CAD data aggregation and clash detection are not available. Mobile and online sharing of 3D designs. So once again, you have this great idea, but how are you going to then communicate it to your customers and other coworkers for review? So the answer to that is shared views. In just a few clicks, you have an online representation of your design that can be opened anywhere. People can access it. They can access your design. They can make comments. They can measure the geometry. They can section it. They can explode it. And they can even mark it up and redline it if there are any questions or concerns. So for SolidWorks, this technology is only available as an add-in for all three levels. So let's stick with interoperability for just a little bit. Let's talk about BIM, Building Information Modeling. This is the foundation of digital transformation in the architecture, engineering, and construction space. So participating in BIM projects is now easier than ever for those of you that are looking to get spec'd in building projects. Or if you're collaborating with architects to design and make custom designs for buildings. Your designs may be highly detailed and ready for production, and you love it, but architects don't need all of that detailed information in the 3D model. In Inventor, they can be quickly simplified using automated tools and then authored as BIM objects. Then there are those of you who create custom fabricated designs for building projects, like staircase designs or awnings. Many times you need the Revit data to work around. Beginning with Inventor 2023, data exchanges can now be sent directly from Revit to Autodesk Docs. Using the Forge viewer, users of Inventor can then access the Revit view they need and include it in their project. It even remains associative if the Revit user uploads a revised data exchange. So this, of course, eliminates the need to email Revit files and revisions that need to be imported into Inventor. So in point clouds, you can register, mark up, and measure reality captured data that is ready for 2D and 3D applications. As mentioned before, this data can be imported into Navisworks and used for walkthrough, fly-throughs, and clash detection. As far as Solidworks, this type of product is only available in their premium level. For manufacturing, we have Autodesk Inventor CAM and Fusion 360. They provide a seamless workflow from design to manufacturing because it's integrated in both products. It includes functionality for 2.5 to 5 axis machining, as well as lathe and mill turn applications. For 2.5 axis machining, it's standard milling operations, 2D roughing and pocketing, drilling, facing, and contouring. For 3 axis, we're talking about 3D machining strategies, including parallel, contour, scallop, horizontal clearing, and more. For 5 axis machining, it's 4 and 5 axis features for machining complex models. The advanced roughing strategy, it's roughing strategy available for clearing large quantities of material effectively. Turning and mill turn, it's a combination of turning and milling features on lathes with powered rotary tools. In regards to Solidworks, Solidworks does provide 2.5 axis in all 3 levels, but the remaining technology does require an add-on. For nesting, when you have multiple flat components that come in different shapes and sizes, it can be challenging to create a nested layout that produces a minimal amount of material waste. Autodesk Inventor Nesting is an integrated nesting software that helps you optimize yield from raw material. So nesting studies can be created and then updated to reflect any changes to your design. You can easily compare nesting studies to optimize efficiency and use Inventor CAM for the laser cut toolpaths. Same as before, this is available in SolidWorks, but only as an add-on. So as far as the, basically, it's kind of like the total of some of the reasons why people are choosing Inventor or the collection over SolidWorks. And in addition to that, we have very flexible subscription options. You have the ability of doing quarterly or annual basis. And there's also even a token-based system where purchase a technology, use it when you need it, and just save those tokens for at a time when it's actually necessary. So we're right about on time. I'd like to open up to any questions or Q&A that if anything that's out there. Juliana, if there's any questions that need to be answered or addressed.
Thank you, Jim, for that wonderful presentation. As of now, I don't see any questions, but I wanted to tell you all about our upcoming events. We have coming up next on June 15, 3 interoperability tasks between AutoCAD and Revit. And then on June 22nd, we have What's New in Civil 3D 2024. And then we have a very interesting one on June 29, Autodesk usage report. So yeah, all of this are 1 p.m. Then What's New in Civil, it's at 11. But yeah, please make sure to check our website. We have all of our events there, so you can register on the events section. So yeah, if you want to learn any of these topics in detail, you can always take a custom training with Jim or someone else on our team. We also offer group classes online. So yeah, again, be sure to be checking the website for future webinars. And I think that concludes our webinar today. Thank you, Jim, so much.
Thank you, everyone.
Have a great day. Bye bye.
Thanks. Bye now.